Okay, so we're going to finish up with 8.4, which is going to do a little bit more with writing complex numbers in trig form. So we've already looked at how to multiply, how to divide. What we're going to look at now is how to raise to a power and how to take a root. Okay. So what I want to do is, I'm not going to go through the whole kind of proof of this. I'm going to show you what would happen if you raise this number to the second power. And what I'm more interested in is, do you see a pattern? Like, do you see what happens to r? Do you see what happens to theta? Here's a complex number that we're starting with. I'm calling it z. Z has a radius and it has an angle. If you take z and you raise it to the second power, this is what you would get. So what I'm hoping is you see a pattern that happened there when I raised it to the second power. Again, we're not really going through the proof of that, because I want to focus more on actually doing problems than proving a formula today. So anyone think they know what z cubed would be based on the pattern for z squared? Which again, we didn't prove it, but yeah.
It would be r cubed cosine 3 theta I sine 3 theta.
Yeah. So that's what you would get if you were to cube it. Now, how about if you raised it to the nth power? And this is basically the formula in general. Anyone tell me that one? So look at what's happening to the radius. And then look at what's happening to the angle. You're going to do the same thing you would do if this was a number, except now it's a letter. Yep.
So just r to the n, parentheses cosine 3n, or n theta.
Yeah.
Plus I sine 3n. No, n theta again. I said that all backwards.
All right. So basically, can someone describe to me, how are you getting the radius here? You're taking the radius and doing what with it? Let's see, how are you getting the radius each time? Yeah?
Raising it to n?
Yeah, you're raising the radius to the power. So you're raising it to whatever the power is. If it's 2 or 3, or in this last case it was n. So you raise the radius to the power. And what about the angle? How are we getting that? Yep.
You're multiplying it by n.
Yeah, you're multiplying the angle by the power. So this formula really saves us a lot of time to raise something to a power, because imagine you had something in standard form, like 3 plus 2i to the 12th power. If you want to do that up, and you're not in trig form, that means you have to write 3 plus 2i. You have to write that 12 times. And then you have to FOIL every set of parentheses together. Right? That's going to take a long time in standard form. If you convert this to trig form by pretty quickly finding the radius and finding the angle, then you only have to do 2 things. Take whatever radius you get here from the Pythagorean theorem and raise it to the 12th power. You're half done. Take whatever angle you get from doing the inverse tangent and multiply it by 12. Done. That's all you have to do. Right? Compared to standard form having to do hundreds of steps. foiling. Not hard steps, but lots of steps. Right? This is going to take way too long to write this out 12 times and do all the foiling. So this idea of raising the radius to the power and multiplying the angle by the power, that's called DeMoivre's theorem. So if you take, you already wrote this down, but if you take a complex number and you raise it to the nth power, you raise the radius to the power and you multiply the angle by the power. It's exactly what we just wrote on the other page. So the key to using this formula is that you have to have a number in trig form. If it's already in trig form, well, great, it's going to be real easy. If it's not in trig form, okay, well, we got a little bit of extra work. We got to use Pythagorean theorem, get the radius, and then use inverse tangent to get the angle. But this is still going to save you time. The only time it wouldn't really be worth doing is if, like, you were just raising something to the second power. Honestly, if I had something like that and I had to square it, I can square that in my head, and I can write it out. To take that, change it to trig form, and then use this DeMoivre's theorem, that's going to take even longer. So DeMoivre's theorem really starts to save you time when this exponent gets bigger. Like, even if this exponent was a 4 or a 5, that's big enough that this theorem is going to save me time. Never mind if the exponent was like a 30 or something. By the time it gets even to 4, it's going to save you time. Any question on the pattern of what you have to do there? All right, so let's try it on this one. So kind of a border case whether or not using DeMoivre's theorem is really going to save you time because it's only to the third power. But that also means we're not going to have numbers that are too big. So it's a good one to start with. In order to use DeMoivre's theorem, what do you have to do with what I just put a box around? Yep.
Find the radius and theta.
Yep, we have to find the trig form of that number, which involves the radius and the angle. So, let's figure these two things out, just like we did in the homework. And Casey, what quadrant am I in? Bless you. Yep, we're in quadrant 1. So write 1, and then we're going to go up 1.7. So it's somewhere in quadrant 1. Now, I'm going to find the radius. Anybody tell me what you get when you do the radius? Do out the Pythagorean theorem in that? Yep.
2.
2. You're going to square the 1, square the square root of 3, and that gives you 1 plus 3, which is 4, and then take the square root. Alright, so there's my radius. And now I got to find my angle. What trig function do we always use to find the angle? Sometimes we have to add 180, sometimes we don't, but we always use this trig function. Yep.
Inverse tangent.
Inverse tangent. Matt, do I have to add 180 when I'm in quadrant 1?
No.
No. So we're just going to use inverse tangent of, and Abigail, can you tell me what I'm going to take the inverse tangent of? Yep, so inverse tangent of square root 3 over 1. So really, I could just write square root of 3 when I type that in. And that's a special one, so when you do that, you will get 60. But if you want to check it, you can. There's your angle, 60. Alright, now we've got what we need to write this in trig form, and then we'll raise it to the third power. That's going to be easy. Right, this part actually is going to take longer than we just did. So, r cosine theta plus I sine theta. And we're going to take that and raise it to the third power. So, Jack, what will my radius be when I raise that to the third power?
Would be d6 parentheses.
Can you tell me, how'd you get 6?
Oh, I meant 8
How'd you get 8?
square root that 2 and then cube.
Yeah, 2 cubed.
Yeah.
So you're going to take the radius, raise it to the power of 3. That gives you 8 cosine.
Yeah.
And, yo, what's my angle?
60 or
Well, it was 60 originally, but I'm cubing it. I don't know why I forgot to write it right here. Can someone tell me what my angle would be? Matt?
180.
180. How'd you get that?
3 times your degrees.
Yeah, 3 times my angle. 60 times 3. And that is the answer to this problem in trig form. Any questions how we got that? Now, let's say they asked you to write your answer in standard form. Well, to get this in standard form, all you have to do is type this in on the calculator and see what you get. Right? So we're going to take and distribute this 8 to cosine 180 and sine 180. Right? So let's do that out. So let's first do 8 times cosine 180. 8 cosine 180, and I get negative 8. Plus, now let's do 8 times the sine of 180. The I is just going to stay right there. But we have to multiply that by 8 sine 180. 8 sine 180 is 0. It's because the sine of 180 is 0. And 0 times 8, still 0. So what does that simplify to? Negative 8 plus I times 0.
Negative 8 plus I.
Unless if this was a 1, I would agree with you. Negative 8 plus I, but
Negative 8.
what is it?
Negative 8.
Yeah, negative 8. Right, so that I times 0 disappears when you do that out, and you get negative 8. That's the answer in standard form. Negative 8. You could put plus 0i if you want to, but. So, any question on how we changed it from trig form to standard form? Definitely something you should know how to do. Yeah.
It's not necessarily on that part, but the other part. So you have like the 3 for like you're cubing the equation,
Mm-hmm.
but you multiply 60 by 3 instead of cubing it.
Yes.
Okay.
Yeah. It's not, you don't cube the angle.
Okay.
It's the angle, pretend like times, and then your power.
Oh, okay.
The only thing you raise to a power is the radius. That's the only exponent when you do it out. Other questions on that? Yes?
How'd you get negative 8?
Negative 8?
Yeah.
That's when I distributed 8 times the cosine of 180.
Oh.
And then when I did 8 times the sine of 180, I got 0.
Oh.
And the I just stayed right where it was, but then multiplying by 0 cancels it out. All right, let's Let's try this one. I just want to fix how I wrote it. So negative root 2 over 2 plus root 2 over 2 I. And you gotta get used to seeing the I in different spots. You could see it after the number, you could put it before the number. It's the same thing. It doesn't matter where you put the I. In standard form, that's usually where you put it. You put it after the number. In trig form, they put it before the cosine. Just how to do it. All right. What are the two things I need here to change that to trig form? Well, is that? So what are the two, not how, you don't have to tell me how we find anything. I just want to know what are the two things I have to figure out to write something in trig form from standard form. And it's the same two things we had to find right away in the last problem.
So, like the degree.
Okay, the angle. So that's, yep, that's one thing. So I need that. And what else do I need? Yep,
Radius.
I need the radius. So if we're gonna write that in trig form, we need those two things. Now, technically the problem didn't say to change this to trig form. Good luck, I'll see you in about 15 minutes if you're not going to change it to trig form. If you're going to do that in standard form, it's going to take a little while to FOIL out 8 sets of parentheses. And make sure you do everything right, and you've got fractions, and you've got roots. It's going to be a mess. So, we're going to change to trig form. Okay, let's graph it. We know that we've gone left and we've gone up. So we're somewhere in quadrant 2. This side is root 2 over 2. And that side is also root 2 over 2. I think we did this one in the homework. What's the radius here when you do that one? Yep.
It would be negative 2 over 2.
So I'm just measuring the length here, not necessarily the direction.
Oh, okay.
Yeah. Anyone remember what we got when we did Pythagorean theorem for the radius on that one? Yep. 1. Because this was 2/4. Because when you square it, the negative goes away. So 2/4. This is another 2/4. And when you add 2/4 and 2/4, that's 4/4. Take the square root of 1. Okay, so we've got our radius. And now, let's find our angle. Right, Bailey, what trig function do we always use to find the angle? So not a theorem, it's the name of a trig function. Like if you were to, you want to basically figure out what that angle is to right there. So actually, to make that less confusing, we're trying to solve for this angle. Close. A regular trig function will solve for a side usually.
Inverse.
Inverse. So we're going to do inverse tangent. We'll fill that in. But what do we have to remember to add here? Because we're in quadrant 2. Yep. 180. Yep, we got to add the 180. Now, it's going to be the inverse tangent of y over x. Y is root 2 over 2. X is negative root 2 over 2. What do you get when you divide y by x? You don't have to divide them beforehand, but that's going to be really annoying to have to type all that in on a calculator, because then I'm going to have a fraction divided by another fraction. But really, we should be able to divide those two pretty quick. Yeah? Negative 1. They're opposites. You're dividing positive root 2 over 2 by negative root 2 over 2. So it's a lot easier if you just type in inverse tangent of negative 1. That'll give you negative 45. You type it in. And what's 180 plus negative 45? Tyler?
That would be 135.
Yep, 135. So that's the angle that I drew earlier right there. 135. All right. Now, the easy part is raising that to the 8th power. We can just use our calculator and type it in. So we have r cosine 135 I sine 135. All right. Matt, what's going to be my radius?
1.
1. It's going to be 1 to the 8th power, but it's just going to be 1. And Abigail, how am I going to find my angle? Hey, we're going to multiply 135 times 8. Now, when you do that, you get an angle of 1080. Kind of the same situation as if you had a negative angle. Usually we don't want to write an angle that's that big. So what could you subtract from that to make it smaller? If they asked you to make the angle between 0 and 360. Yep.
Subtract 360.
We can subtract 360. So we do it once, do it again, we actually do it one more time, and really, the angle here is just 0 when you make it as small as you can. So writing 1080 is the same as writing 0. Any question on how we got 1080? Or how we got 0 from that? All right, and that would be your final answer in trig form. If they want standard form, again, you can just do it out if you want to see it. Take the cosine of 0. If you just trust me when you type that in, you will get 1. Take the sine of 0. That'll give you 0. So I just plugged in these two things on the calculator. Got my answers. What's I times 0? Yep.
0.
0. So basically what's happening here is the imaginary part of this answer is 0. It goes away. It doesn't always go away. But in this case it did. So now all you're left with is 1 times 1. So the final answer to this problem is 1. And that's it. Question on that? So 1 is standard form, and 1 cosine 0 plus I sine 0 is trig form. Now, let's go back to the first one we did. We took what was in this box, we cubed it, and we got what was in that box down there. Okay, so when you cube 1 plus root 3i, you get that. How do you undo cubing something? Like if you wanted to undo raising something to the 3rd power and bring it back to what it started with. Yep.
You take the root of it.
Which root?
Well, if you cubed it, then you would do a cube root.
You would do a cube root.
Just for
So if this is what we got when we cubed that, then if you cube root -8, you should get back what you started with. And you would. One thing we have to remember when we take a root is there's always as many answers as the root you're taking. So if you're doing a problem about a cube root, you have to find 3 answers. If you're doing a problem about a 4th root, 4 answers. 10th root, 10 answers. Okay, on the test, I would expect anywhere between 3 and 4. Cube root or 4th root. Right, so that's the last thing we're going to look at. How do we do a root? Alright, so we already answered this question. This is just kind of something I was asking you guys. How do you undo cubing something? You cube root. So in other words, if you take the answer that we got, which was -8, and you cube root it, you will get back what we started with, 1 plus root 3i. At least that's one of the 3 things that you get back. So the whole key to being able to cube root something, or square root something, or do anything, is going to be trig form. Okay, we have to do it in trig form. So I think what we'll do is, let's just go through an example, and I'm going to show you how to set up this example, I think, rather than give you steps without an example. I think with numbers it'll make more sense. So first of all, for all these problems, what you're doing is you're setting up an equation that looks like this. Let me give you another example, just kind of something you can visualize, and then we'll come right back and do this one. So I just want you to watch me write this down. What if I said find the square roots of 16. What that means to do is basically set up an equation. If somebody didn't understand what a square root meant, but they understood what an equation was, I'd say, okay, well, if you understand equations, this means to do this. If you can figure out how to solve this equation and get z, then you know the answer to the square root of 16. Square root means you can raise something to the 2nd power, and it will come out to 16. In this case, it would be 4. If I said, like, find the cube root of 64, and then someone said, I don't understand what cube root means. I said, okay, that means think of a number you can raise to the 3rd power, and it will come out to exactly 64. If you can figure out what number to the 3rd power is 64, then you've just figured out the cube root of 64. So that's the basic idea of the equation we're going to set up each time. This always represents the root you're looking for, and that represents what you're taking the root of. In this case, it's a cube root of 64. Cube 64. Square root of 16. In this one, we're going to do the 4th roots. That's why there's a 4 here. And just to get used to when you see this, unity just means 1. I don't know why sometimes they write that. It's just a special way to write 1. But if you don't like the word unity, just cross it out and write 1. Right? So find and graph 4th roots of 1. All right, so the first step is we're going to substitute the following. I'm going to substitute in for z. So substitute, let's say it like this, substitute r cosine theta plus I sine theta for z. Because z is what we're trying to solve for. Okay, we're going to try to figure out what the 4th roots of 1 are, and we're going to write the answer in trig form. Well, when you write it in trig form, the answer is going to have a radius. I don't know what it is yet, so I'm just going to call it r. And the answer is going to have an angle. Again, I don't know what it is yet, so I'm just going to call it theta. So I'm just representing the answer to the problem right now generically in trig form. I need to figure out these two things in there. So let's substitute that in for z. So now you're going to have r cosine theta plus I sine theta to the fourth power. And this should kind of look like something we did earlier. Hopefully we remember how to do this out in a second. And now you've changed the left-hand side to trig form by doing that substitution. Change the right side to trig form. How do we do that? That's what we learned yesterday. If the 1 confuses you, think of it like this. There's no imaginary part in this problem. 1 plus 0i. So substitute in that for the left-hand side and change the right-hand side to trig form. You can graph it if you need to, but this one's really not too bad. There's your point. 1 plus 0i. What's my radius from that point to the origin?
One.
1. Is there any question why the radius from, or the distance from the origin to that point is 1? All right, and how about Eli, what's my angle?
0.
0, yeah. That's right on the axis. And when your point is right on the axis, you don't have to worry about using inverse tangent or any of that. It's right on the axis, so it's just 0 degrees. All right, so you substituted in r for z, okay, what we just wrote right here, r cosine theta, I sine theta, and you change the right-hand side to trig form. Now, the right-hand side is going to stay the same in the next step. So I don't like to keep copying it over too many times because it's kind of a lot to write. But can somebody tell me how to do out the left-hand side using DeMoivre's theorem? Sarah?
It would be r to the fourth cosine 4 theta plus I sine 4 theta.
Yes. Okay, now, how many variables are there on the left to solve for? Yeah.
4.
Okay, can you name what they are?
Never mind.
Sarah?
2.
2. R and theta. So those are the two things we have to figure out. And that's the answer to the question, the 4th roots of 1. All right, well, this is the radius on the left. It's r to the 4th. What's the radius on the right? Yeah? 1. You're going to set those two things equal to each other. So take the radius on the left and set it equal to the radius on the right. So this is the equation for the radius. We'll come back and solve that in a second. Now we need to set up an equation for the angle. What's my angle on the left? Chris?
4 theta.
4 theta. What's my angle on the right? Yep. 0. Now, I said to you, when you're finding a root, you always get as many answers as the root you're finding. So we're doing a fourth root, we need 4 answers to this problem. Well, the radius is going to be a single number. In this case, when you take the fourth root of each side, you can solve for r in a second and you'll know what r is. So the different answers come from the angle. If you left your equation like this and you solved it, you would be right. But you would only get 1 out of the 4 answers by dividing each side by 4. To get all 4 answers, you have to add something on the end right there. And what you want to add is that, plus 360 times k. That term right here is what's going to generate the other answers to this problem. The thing is, well, what's k? K is every number, every integer from 0 up to 1 less than your root. So we're finding a fourth root. So we're going to plug in k equals 0, 1, 2, 3. That's how we're going to get our 4 different answers. So k is a number that starts at 0 and it goes up to 1 less than 4. So 0, 1, 2, 3. So you're going to have to do 4 calculations to find your angle. You'll have 4 different ones. All right, let's do the radius first. If you take the fourth root of each side, you could use your calculator if you need to, but the fourth root of 1 is 1. 1 times 1 times 1 times 1 is 1. Now here, this is correct. Okay, 4 theta equals 0 plus 360k. But it's a little easier to think about it, instead of thinking of quadruple your angle, just to think about your angle. So how would you get rid of this 4? So theta would be by itself. Sarah? Just divide by 4. Now, this is kind of a special case because this part is 0. You technically don't even need to write this part. If it wasn't 0, you would. But in this case, it's 0. So if you want to leave it off, you can. If you want to put it, you could, but it's just going to be 0 plus something. So that's going to cancel. That's just 0. And in the simplest form, that's the formula for your angle. Theta equals 90k. 360 divided by 4 is 90. All right. Now we've done all the work we need. We just have to write the 4 answers. So we're going to have an answer when k equals 0, k equals 1, k equals 2, and k equals 3. Every single answer is going to have the same radius. So if we want to write all those out right now, we can. The radii, or the radius, is 1. I'm not saying it's 1 in every single problem we're going to do. It's just, it happened to be 1 in this problem. Okay, so, and they all are the same. I just left room to write in all my angles. All right, so the first value we're going to plug in for k is 0. What's 90 times 0? Okay.
0.
0. There's your first angle, or your first answer. All right, now k equals 1. What's 90 times 1? 90. There's your second answer. What's 90 times 2? 180. There's your third answer. And what's 90 times 3?
270.
270. And those are all of the fourth roots of 1. I'm not going to graph them, I'm not really worried about that. Those are the fourth roots of 1. You could convert any one of those into standard form. You'd have to distribute out, again, you really don't even need the 1 here, but just to practice writing it. If you distribute the 1 out, you could change these to standard form. And we practiced a little of that in the homework last night. All right. Question before we take a look at it, I'll try one more of those. But that's finding roots. That's the one I think is the hardest. All right, let's do this one. Fifth roots. So not too bad, a little bit more than you probably have on a test, but it's still a good example to look at. All right. So, can somebody tell me what we said you substitute in for z? What's the first thing I should do on the left-hand side? Yep.
R cosine theta plus I sine theta.
Alright, so you're going to substitute that in for z. Now, if you wanted, you could have done that to the 5th power at the same time and brought yourself right to the next step. But if you don't want to, just do that in the first step. Now, what do you have to do with 1 plus I? We can't leave it as 1 plus I anymore. Well, what format is 1 plus I when you're talking about complex numbers? What's the format of that number? Yep.
Standard form?
That's standard form. What form do we have to put it in? Yeah.
True.
Yeah, we got to get it in trig form, which means what 2 things do we need to find? Yeah.
The radius and the theta.
Yeah, we need the radius and we need theta. Alright, so let's find those 2 things for 1 plus I. Again, if you want to sketch it, that's fine. You can make a sketch and then just kind of see, you know, what it looks like. 1 plus I, right 1, up 1. So there's essentially your problem if you want to visualize it. What's the radius? Yep.
The square root of 2.
The square root of 2. If you want to just write 1.41, we could round it off, that's fine. If you want to leave it as square root of 2, we could do it that way. Let's just round it to 1.41. So there's my radius, cosine, and this is a type of problem we've seen it before where the amount you go over and up is the same. So does anybody remember what kind of angle that is when you go over and up the same amount? If not, this is where we would use inverse tangent of y over x to find theta. But it's going to be the inverse tangent of 1 over 1, which is just the inverse tangent of 1, which has a nice answer.
45.
That's a 45-degree angle. Again, if you didn't know it, just go on your calculator. Inverse tangent of y divided by x. It's 45. You don't add 180. That's different quadrants. So there's your angle. All right. So now, take the left-hand side, and you know what? So we don't have to rewrite the whole thing. I'll just fix this one. Can somebody tell me what happens to this? when you raise it to the 5th power? What happens, what does the r change to? Yep.
R to the 5th.
So this is going to change to r to the 5th. And what does theta change to? Yep. 5 theta. Honestly, that's the step I usually just jump to right away. So I've taken care of that 5. Oops. So r to the 5th and 5 theta. Now, how many variables do I have on the left to solve for? Yep. 2. I have a radius on the left, and I need to set that equal to my radius on the right. So r to the 5th equals 1.41. What's my angle that's on the left? Yep. 5 theta. And what's my angle that's on the right? You like?
45.
45. So you set the radius on the left equal to the radius on the right. You set the angle on the left equal to the angle on the right. Now, if you stopped there and you said, all right, I'll divide each side by 5, 45 divided by 5, 9. You're right. Theta is equal to 9 degrees. That's one answer. But you're going to lose the other ones. Unless you put a plus what on the end? Yep.
360K.
360K. That's a term that generates the other answers. Okay, so this one, you just want to use your calculator and take the 5th root of both sides. It's been a little while since we've done a root higher than a cube root, so just to remember how you do it, put in your index, math, number, no, math, actually option 5, it's the first menu that comes up. Option 5 will do a x root. You just put in the number of the root you want to do first. So the 5th root of 1.41. That's about 1.07. All right, so if we want to start setting up all our answers, we can get that ready. 0, 1, 2, 3, and 4. Remember, this is a 5th root, so you're looking for 5 answers. 0, 1, 2, 3, 4. It's always one less, the number at the end is always one less than the root. Alright, so 1.07 cosine, phi sine. Alright, what I'm going to do is just go like this and copy it a bunch of times. Okay, so we've got all our answers set up. They're going to have the same radius each time. Now we need to find our angles. Angle is going to be different every time. What should we do to make this formula a little bit easier to work with? Instead of having 5 times our angle, what could I do? Yeah.
Divide by 5.
Yeah, just divide everything by 5. Right? Okay. Yeah. So 9 plus 72K. Now, fill in 0 through 4 and write your answer. Okay. What's 72 times 0?
0.
Plus 9. 9. There's your first angle. All right. K equals 1. What's 72 times 1? Yeah.
72.
And what's 72 plus 9? 81. So all that's really gonna happen each time here is you're gonna add another copy of 72. So let's just take the calculator and do that quick. 81 plus 72 is 153. All right. Add it again. 225. And add it again. 297. And those are all your answers. All right, so let me put up on the board real quick about the take home. So remember, no homework from the book. Okay, the take home will be 5 questions. You'll do the other 5 questions in class tomorrow. So there'll be time limit of 70 minutes. I don't think it'll take you more than 70 minutes to do 5 questions. This will be due by, say, 7:50 a.m. So it'll be due right at the beginning of first period. 7:50 a.m. on March 11th. If not done, then it's a 0. Any questions? Yes.
Can I get a time zone on that 7:50?
That time zone, yeah, we get a time zone on that. That's an EST,
Okay, thank you.
Eastern time, and that's 2022. Not like 2025 or anything. All right. If anybody is concerned because they're like, you know what, my internet doesn't work at home, I can't do it, come talk to me. And if you can't do it at home, then I can let you do it in person. You'd be able to use all your notes in person because you can use all your notes at home. Yes?
Will we be allowed to like get on and off of it? Because sometimes my Wi-Fi will drop and it'll come right back on.
Yes, you'll have a total of 70 minutes. Just don't, like, if you're gonna stop and pause it, close it out. Because if you just let it sit there and you walk away and you come back in 2 hours, it's gonna say you're done.
Okay, alright.
Yep.